Okay, so hello, today I want to talk about the idea of open problem fields and how we implemented this via a quite visual example, namely tilings of the plane. And we are, so I'm Dennis Arikaya, a PhD student in philosophy from the University of Hamburg, and my co-author Karl Heuer is a postdoc in mathematics and computer science at the Technical University of Berlin. And the idea of open problems fields is quite straightforward. We start with an accessible initial question. So in our case, which converts regular n-gons admit a tiling of the plane only using one type of tile. And this question can be solved by children. After some doodling, you will see that triangles, squares, and hexagons are the only such tiles. But even more important than proving that those are the only one is to find new questions. And we argue that this draws a more adequate picture of mathematical practice. And you can vary, for instance, the word 1 for 2 or k. So the first question would be for Platonian tiles, and the second one would be for our Archimedean tiles. And you can even be more general, and being more general is like another crucial notion. By dropping adjective or assumptions, you can come to more general questions to ask for which figures admit a tiling. You can change the object you want to tile, so going from the plane to a bounded plane or just a circle, a pizza, so to speak. And there you can quickly reach open problems like the question for tilings of the circle, where the middle point lies within one tile, is still an open research question. And when we change it to the space, there comes another important aspect into play, namely the tension between notion. What should be a tiling of the plane? You might, the tiling of the space, you might switch your definitions a little. And this adapting might yield to more broader fields of studies. And the example will be explained in more detail in these two papers, but Karl will try to give a short idea in a few moments.
Hello, and yes, as Dennis argued, so what we did is we created a series of worksheets from the idea for a project weeks within schools, but also used for online enrichment courses now during the Corona time, and this over several weeks then. Yeah, and we also started with this more basic initial question, but also this is already very, very visual. And here we have an example of some Platonian tilings and also other tilings of the plane. And from this, on the first day, we went on and made some detours into the society, mainly with the work of Escher and his Symmetriezeichnung. And this is actually an example of one of our participants who created its own ones by understanding how Escher formed those Symmetriezeichnungen. Yes, and then we went on by varying the problem again and considering the third dimension. So what we were looking at were Platonian solids. And yeah, we tried to characterize them, prove which one existed, but also we asked them by wending on in the same spirit, which regular n-goms can even form polyhedra. But still, this is just one aspect. We also had in mind this tiling of the space, and there we have a much more complicated problem, which was also tackled or at least worked on by our students. And even there, you have to have a very good visual understanding. And in the end, we went to something very, very deeply within mathematics, namely Penrose tilings, so-called quasi-periodic tilings, by initiating new concepts like periodicity. Yes, thank you very much for your attention.